And in this video today, I'd like to talk about Industrial Craft's nuclear reactors. To be precise, IC2. Some reactors are incredibly stable, like this one for example, which is basically here an air sort of cooled reactor that I put together a few minutes ago. This reactor is inherently safe. It is not possible for this reactor to develop enough power to blow itself to pieces, because too much heat is being driven out of the reactor by these overclocked vents. This here is going to be our high power reactor. Now I should put an emphasis on the high power. This thing can produce something in the neighborhood of 10,000 EU. And in order to do this, we need to do a few tricks in order to make it work properly. The first trick is that we're going to have to preheat the reactor. To do this, I would suggest using a bit of uranium. 2 things of quad uranium will do the trick, and we're not going to use these as the fuel for this reactor, of course. Okay, so we're going to wait for the reactor to build up quite a substantive amount of heat. The reason for this is because when we install the MOX fuel, we need to get the maximum amount of power out of it. Preheating the reactor, has a very interesting and very helpful effect on the actual MOX fuel. When you have a heated reactor and when you install MOX fuel, you multiply the power of said fuel. And in order to get the 10,000 EU, we need to heat this reactor basically to the point where it's going to blow itself to pieces. So we keep waiting, and just before it overloads, we're going to remove this. Now as you can see here, the reactor is basically heated near the point of just exploding. If you were to leave this to go for maybe a few seconds more, this reactor would have detonated and killed us. So already this reactor is very, very dangerous. Now we need to move on to the part where we're going to install the MOX fuel. Now what we're going to do is we're going to use quad MOX fuel cells. This stuff is basically just uranium and plutonium. Now what we've basically created here is a barely controlled bomb. I'm going to remove that for safety reasons, because if you switch it on now, you will just explode. Okay, now here comes the part where we need to configure the reactor correctly. Now, we of course need to select the cooling. We're going to install our coolant cells first. I would recommend using 60k coolant cells, or else you're going to burn through these 10k ones in seconds, because we're going to be pumping so much energy through this reactor, and these rods are going to produce just so much heat that if we don't properly cool them, it's just going to be an explosion. So we're going to put our coolant cells here, and we're going to try to leave spots where we can install the neutron reflectors to maximize the output of this reactor. Now because we've preheated the reactor, the moment we switch this on, these quad fuel cells will have, of course, the energy in them multiplied by the fact that, MOX, when you expose it to heat, puts out a lot more energy than just MOX in a cool reactor. So we'll put in our neutron reflectors on this side, and we'll put another reflector here as well. And we'll install our cooling cells on this side as well. Unfortunately here you are limited to how many cooling cells you can jam into a reactor, unfortunately. Okay, because we can't put any more, of course, put any more stuff into this reactor, we're basically just going to have to go ahead and use what we have here. Now, a word of warning here, this reactor is basically it's basically just a barely controlled bomb. If one of these coolant cells fails here, the energy that cell will pump into the reactor would push the reactor over the line and blow it up. Once you start this reactor, if one of these coolant cells here fails, at this temperature, it will just go off like a nuclear weapon. So, I cannot emphasize how similar this is to just basically a barely controlled bomb. Unlike on other versions of Feed the Beast, you can push reactors as far as you want as long as you keep them within the thermal limitations. Now the heat that we have produced, that we put into the reactor, is amplifying the energy of the MOX fuel, and the reflection of the neutron reflectors are also pushing the rods a little bit further than they normally would go. As you can see here, we're going to chew through these coolant cells very quickly. So we're producing about 12,000 EU. And it looks like we're absolutely charging this thing like a rocket. There are very few actual uses for this reactor apart from maybe producing absolutely huge amounts of energy. And I would recommend being extremely careful with this reactor because I cannot emphasize it enough, it's just a barely controlled bomb. This thing over here will run day in, day out without problem. In fact, you could pretty much just leave this and it would never ever run into issues apart from perhaps depleting its fuel supply. Because I'm in an area where there's a lot of taint, I'm going to allow this reactor to explode, as it would wipe out a decent portion of the taint, as this is just basically a nuclear weapon. Assuming you have a large supply of coolant cells, you can keep restocking this reactor and keep drawing energy from it over and over again if you ever do, of course, want to basically just want a humongous amount of power very quickly. Now, I'm going to bring this reactor offline and I'm going to eject these cooling cells. These ones here, because they'll die short of all the other ones. So we'll put in our cooling. Get a bunch. Oh, that's 30 Ks. We don't want those. Okay, let's try again. Now the reactor will burn through all of these cooling cells. Once one fails, the thermal energy these rods will put into the reactor will detonate it. So it's basically just counting down to find the weakest link. Looks like this one's going to fail first. Now this reactor is, to say the least, extremely volatile. Once one of these goes, it'll just throw the thermal output, you know, to absolutely stupid levels, because we're pushing incredible amounts of energy out of the MOX fuel. So it looks like we are going to have a detonation pretty soon. Come on. Yeah, once you get up to about 10,000 on this cell, it's just basically going to explode. Alright, it's going to blow up just in a few seconds, and I'll give you guys an idea of just how big this is going to be. Basically here, you know, the saying that the reactor is a barely controlled bomb is an understatement, and it's done quite a lot of damage, as you can see. Anyways guys, thanks for watching this video. I thought I might just show you how to make, you know, the barely controlled bomb reactor. And I hope that you enjoyed it. I'm not certain if you can get any more power out of the reactor. To the best of my knowledge, you can't really cram more into it than that. I might be wrong. Someone might be able to put all 4 blocks in and try to force power out of it some other way. But yeah, with using the effects that MOX fuel has, you know, by of course amplifying its energy using heat and neutron reflectors, you can force more energy out of the reactor and in turn increase the overall power output. But yeah, I'm using IC2, and I hope you guys enjoyed this little demonstration and this little tutorial on how to squeeze a crap ton of energy out of a reactor. That's all. See ya.